Okay, so the recording is going. Welcome to week 7 for Neti 105 Spring 2015. This is not just the Richmond. We have students from around the state or that are enrolled statewide. This is one of the pilot programs to where we can have a online seminar for all students in the Neti 105 course. And we've already piloted this same type of thing with accounting courses and some of the math, maybe math courses, but I know the accounting course did, maybe a business course. And so I volunteered to do this online because I do it with my students anyway, sometimes with this course. And so I wanted to volunteer and do this statewide. And let me just double check here. Can one of you, Kelly, do you mind, if you don't mind, can you if you go in the question box, are you able to hear me? Is my voice coming through? I just want to double check. I'm always a little bit cautious if I'm actually broadcasting. Okay, great. Thank you. All right, it looks like we have 7 here, so that's we're picking up steam here. We're picking up a few more each week, and hopefully a little bit more as we go along. If you have not attended any of the previous ones, we've got a late start on doing these online seminars. So this is the 3rd one. We started in week 5. Last week we ran, week 6 obviously, and then now week 7. And so what I've been doing is trying to catch up a little bit on the material. Covered looking at the modules here. I covered weeks 1 and 2, the first or week 5, 6 and in week 6, I covered sessions 3 and 4. What I'm going to do tonight, or what my plan is to do tonight, is look through the session 5, the session 6, and the session 7. So I'm going to get us all caught up this week. We will, and let me back up. Are we week 6? Week 7? Let me just double check here. Yeah, we're week 7. We're week 7. I just got thrown off there for a second. Let me look at the calendar here. Let me pull my calendar up. Turn off everything else. And yeah, we're week 7. Week 8 is next week. The Richmond campus has spring break. Then we go into the week of the 9th. So for the students in my class, we'll have spring break that week. There won't be any assignments. You'll need to check with your instructor for your spring break on when you'll have your break for that. So I won't cover that in here. You'll just need to get with your instructor for your course on that. Another thing I wanted to remind you on is you should have done a survey or completed a survey at some point. Your instructor should have given you one. Let's see. That's I'm not seeing where it is. I put mine in week 8. For my students, the proctor exam information. Get with your instructor. You should have filled out a survey so that you can schedule your final exam. The final exams are proctored, and so you'll need to get with your instructor on that to do that. And if you're out of state, if you're not in the state of Indiana, you'll need to work with your instructor on that. If you're in my class, you should have been emailing me and letting me know if you were or taking the survey, and then if you were out of state, email me and let me know, and then we'll work out separate details on that, on how to do the proctoring for that. So let's get rolling here. I wanted to remind everyone that I do post, or these seminars are posted on the Ivy Tech YouTube channel. Let me go back here. You go YouTube, Ivy Tech Community College, and I'm not sure if anybody's found those on there. Christina, is it Christina? And I hope I'm pronouncing it properly. It is the final exam. Good question, by the way. The question asked was, is the final exam the cert? And I'm assuming you mean the certification for Network Plus. And the answer to that is no. The final exam is not the certification for the Network Plus. The final exam in this course is for the Cisco Academy, because the way that Ivy Tech has written this course is 80% of this course is geared towards the Cisco Academy or the Cisco One course. There's 4 courses in the series to work towards your CCNA, your Cisco Certified Network Administrator. So, or if you're going to take the CCNA in 2 parts, course 1 and 2 lead you towards the ICND 1, and which is let me pull up there. Let me pull up the information on that. Let me pull this up. The ICND1, there's two parts. You can either do the CCNA in one exam, or you can do the ICND1 and ICND2. This course 1 and 2, let me go back here to the home. See if I can find this. Yeah, I'm not finding it. Their site's not easy to move around here. The course 1 and 2, the Neti 105, and then I think Neti 115 is the second course towards the Cisco. And this course is about 80% toward learning how to do the Cisco certificate or Cisco routers and Cisco switches and networking. The Network Plus is about 20% of this course, although you have the content in here, and that is what you need to study for to get your Network Plus, and that's through CompTIA. So if you go to the CompTIA.org. Go to CompTIA.org, and I think I need to give that site permission. I had to reset all my permissions on all my sites recently. We go to certifications here, and if you go over here to, oh no, I don't want to do your questionnaire, and go down here to Network Plus. Yeah, but it's got a warble in it. Okay, let me adjust my mic here. Give me a second. Okay, see if that's a little bit better there. Maybe that'll work better. Actually, let me do a check here on my. And lower some of this here. Give me just a second now that you're saying that. I'll fix my device here. Yeah, I'm kind of high there. It's this thing, Windows 8 is just, it jumps around on me. It sets this around depending on, and it won't stay set. Okay, so hopefully that'll be a little bit better there. And go to the CompTIA.org. Up in the upper right-hand corner, you'll see the certification. And then if you click on the Network Plus, this gives you the information about the Network Plus. The exam objectives, you have to put in your email address. Well, you don't have to put in your actual email address. You can do something like, something like that, and it'll still give you the information. And you can select your certifications that you want to pull up, and it'll give you the exam objectives. I think I have mine. Let me pull mine up over here. Let me pull up the exam objectives. It's off screen, but give me a second. I'll pull that up for you. Certification. And, well, thought I had it on here. Oh, there we go. Certification. You put that on the main screen. Go to certification, go to CompTIA, and then if you download the Network Plus, there we go, the N10005. You will see the exam certifications, and these are what you will, oh no. Okay, come on. And then if you go down through, it'll tell you what the exam for the CompTIA Network Plus is going to cover. And Edwin, it might be on, if anyone else is having issues with the audio, just go ahead and put in a question on there and let me know that if it's giving you problems or not. But it might be your connection. Let me give you some tips real quick. One, make sure that you're on a regular wired connection. If you're on wireless, that could be part of it. It could be a bandwidth issue. If you have any other connections in your house, if somebody else is playing Call of Duty on their Xbox or PlayStation, then go ahead and have them log off. Netflix is a huge bandwidth hog, so just make sure other connections on your particular internet are down. And logging off and logging back on, just closing out of the seminar and logging back on sometimes will fix it as well. It's the old shut down and start back up again. So that might help as well. Okay, so once you check out the CompTIA Network Plus, this is the exam you're going to be taking, and you'll work with your you will need to get with your instructor for your course You'll need to get with the instructor for your course. You have 1 year. You have 1 year from the time of the start of the course. Let me see if I can find the Ivy Tech channel. Here we go. You have 1 year from the start of your course to take your CompTIA Network Plus exam, and you would need to take that with your testing center out of your particular campus. So, for example, I'll use the Richmond campus, for example. Those students would contact me, or I would give those students information to the testing center, and then you would go to the testing center and take your CompTIA Network Plus, or if you can't take it at that testing center, or you're out of state, you would have that particular testing center forward your certification or your certificate, your certificate to take that exam to you, so you could go to a local testing center and take that at your local testing center. But you have 1 year from the time the course starts, January 8th, I believe it is, to take that Network Plus. I would recommend doing it sooner than later on that. You also have, and I've showed some other students, if you go to the books 24/7, if you go to Campus Connect for resources, I'll just cover resources here again real quick, since it looks like we have a number of new students in here. I'll show you real quick how you can get some resources. If you go into Campus Connect, go into the library tab, go into and you'll have a library tab for you on there. If you go into the library tab, and then this is the Richmond library, but you'll need to find your library tab. But once you should have books 24/7, and this one's on books, and then books 24/7, and it'll use your login and go there. You'll have to create a whole new login for books 24/7, and I don't think I have mine. Let me see if I can find mine here, books 24/7. There we go. And I'm gonna. I use LastPass. There we go. And then once you get into books 24/7, you should be able to go in, and I saved mine in my personal folders over here, and I've got it saved in Neti 105. But if you look for Network Plus, make sure you're looking for the N10005 exam, because that's the one that's current, is the N10005. And you add that into your books, and you've got resources in here to then go in and, this Network Plus book, I can study this book online. Of course, it's online, but if you want to look at Ethernet basics, that's going to cover, and these books should be mapped to the Network Plus for you. And then you've got material to read on the Network Plus, as well as if you go into the course on Blackboard, you should have material in there as well in your Blackboard course. If you go in there, you should have resources. No, not there. You should have. No, I don't have it on there. Oh, I take that back. It's not there. It is in here. You've got your Network Plus resources here as you go down through the chapter. I forgot we put them over in the Netacad now. So these are your Network Plus contents, and it'll say Network Plus content that you're going to be studying on there. So you're going to study that alongside learning the Cisco, and then you'll take your Network Plus exam sometime within the next year. Okay, so let's take a look at, let's see if I need to go back here. I'm not doing lectures at this point on the particular material, because you can go through the material on, what I've not been doing is going through and lecturing over the PowerPoints. The reason I haven't done that is because I have already done that in another format, and I didn't want to take up, or not that I didn't want to take up, I didn't want to cover things that I've already covered in some other type of recorded format. So what I was going to show you is on the Ivy Tech, if you go to the Ivy Tech, let's see here, and if you look at the uploads, yeah, right here, see, if you go to the uploads section, if you go to the Ivy Tech channel, and go to the uploads here, you'll see that they're doing these for other courses. There's math, there's biology. Here's mine. There's the Neti 105. That was the one that was uploaded sometime. That was the one for last week, and they got it uploaded 3 days ago. You can find those there, or if you go to my YouTube channel, and you can find my YouTube channel if you just search YouTube and you do Jason E. Johnson. You have to separate the initial out, by the way. Separate the initial out, Jason E. Johnson 3-1. If you do it like that, you should be able to find me right there. There's a lot of Jason E. Johnsons, by the way. and you'll see a lot of stuff come up. But once you find me on there, if you can't find me on YouTube, then email me. My email address is jjohnson@ivytech.edu. Now, if you have questions about your course, you need to email your instructor. But I don't have problems answering questions from students, even if they're not my students. If you have just questions in general about IT or just general questions, I have no problem answering questions. I mean, I'm usually fairly quick about getting back with you, or at least pointing in the right direction on that. But if you have trouble finding my YouTube channel, then it's just email me at jjohnson. And I think is there another link I could send out? I don't know. Anyway, once you find my channel, the reason I'm showing you that is if you subscribe to my channel, yes, shameless plug here, but if you subscribe to my channel, I'm not making any money off of it. I mean, it's not. I mean, there's only like 300 people subscribing to me, so it's not like that. It's not a business for me. I do my channel to just put basic information out there for students. So you'll see basic things that I put out here. I've got some playlists out here. If you go down to the playlist, well, you'll see the PowerPoints on here, but if you go down to the playlist down here and you look at my playlist, you will see that those are linked videos. Okay, here you go. Just look down through these, and well, the ones that aren't locked. Here, I tell you what. Let me do it this way. Let me use Firefox here. Let me go to another. Let me go to a source outside here, and I go to YouTube. Okay, Bing, no. Oh, come on. YouTube. Oh, come on. Why is okay? There we go. And then you search for me and put in Jason E. Johnson, and you find me. There we go. And if you go down to my playlist, this way you're seeing what I see, what you see, and you see my playlist on here. If you want to go back through, you'll see where I did seminars in the fall for this same course. I've got information for Network Plus. What I wanted to show you here is I'm also doing these seminars underneath Spring 2015. So if you're wanting to see these replayed and you can't find them on Ivy Tech, I'm putting all those videos up on here. So I've got weeks 5 and 6 on there. But the Network Plus is I go down through and I explain the basics of a binary to decimal, subnetting, the 4th octet, which is the simple subnetting, ANDing, how you do the ANDing process, and I'm going to cover that in one of these seminars, by the way, and then advanced subnetting. And what I've tried to do with those videos is keep them short. I think less than 10 minutes. So that one's 15 minutes. That one's 8 minutes. That one's 16 minutes. I've tried to keep them short, but try to go through and explain subnetting and binary in easy to learn, easy to understand. I did it so I could understand it because I had a terrible time learning subnetting to begin with, and it was just terribly confusing. And so when I set out to do it, that I could understand it. And so that's what I've tried to do. I've also got a playlist for the Neti RNS Course 1, which what I have done is I've taken all the PowerPoints for this course and I've lectured down through those. And you can see the times on them. I've tried to keep them short, but some of them are longer than others, depending upon the material. I've got one on Packet Tracer Intro on how to do that. But then I do PowerPoint Chapter 1, Part 1, Part 2, all the way down through Chapter 8, Part 1s, 2, and 3, and yes, Part 1 I'm explaining IPv4 and IPv6, so they got a little bit long there. IPv6 went 30 minutes, and I apologize for that, but it takes a lot to explain IPv6. And, of course, then I have the subnetting information down there on those. So when you go down through, if you want to get the PowerPoint lecture material, for example, Chapter 6, I take the PowerPoint and I lecture through it. So if you're wanting the lectures for the PowerPoints and I explain the different data, you can view those videos on my YouTube channel. And if you subscribe there, you can see all the new videos that I put up as well. Okay, so that just showing you where you can find some more information on there. And let me drop that. And of course you can find it, if you search through, you can find it on the Ivy Tech site too, but I think it's just easier to find it on mine. Let me close those there. And so what I want to do now is go through, let's see here. Okay, there we go. Yeah, in session 4, you would have had this Proctor Information Survey, and then in my class I put it in session 8 as well. So hopefully you've already done that survey, but if not, get with your instructor. Okay, so now let's take a look at building an Ethernet cable. And I want to look at this. You probably already went through this lab and done this lab because, again, this was from module. Oops, let me back up here. That was from module or session 5. So you've already went through this a couple weeks ago, but I want to go through, and what I'm doing at this point on playing the catch-up cycle here is to see if anybody has any questions on the material. So if you have any questions on how to do a crossover cable, how to do a straight-through cable, any of that, what I want to do is I'm not going to play this video because you can go look at that yourself, but to see if anybody has any questions on Ethernet cabling and how to do cabling. I don't have my camera turned on, or else I would show you some of my tools that I use, but I don't have a easy way to turn my camera on right now without showing you my dirty office. It's kind of in disarray right now. So any questions? If you don't have a question, that's fine. You don't have to put that you don't have any questions. I'm going to clear some of these questions that are already on here. Okay, good question. I'll repeat that here in a second. Any other questions? If there's any other questions, just go ahead and put them in the question box, and I'll get to them. We have one question on here, and I hope nobody. I hope you don't. I'm not going to say the name of who asked the question. I'm just going to repeat the question. We had a question that says, "Are there any pointers on memorizing the order of the wires?" Unfortunately, my memorization of wiring is terrible, or my memorization is just terrible anyway. So when I'm trying to memorize the OSI, I come up with a mnemonic. Please do not throw sausage pizza away. Physical layer, data link layer, the session layer, and then I can learn them that way. Tia, let me see. Ethernet. Now, let me tell you a little bit. Good question, by the way. The TIA EIA 568A and B is the standard for wiring. However, let me tell you that you don't have to use that. You don't have to use that color coding. By the way, if you understand what's happening with these wires, as long as you're getting the wires, as long as you're getting the right wire swapped. If you're doing a regular crossover or a rollover, if you're doing a regular straight through, it doesn't matter what color, which order you put them in, as long as they all match up, as long as brown's on one end and brown's on the other end at the right point. But with that said, you want to do it in the standard, because if you get somebody else that comes in behind you and they look at your wiring, they're going to probably make fun of you. And they're probably going to ask why you did it in that format. And I can tell you, when I first started doing Ethernet cabling back in the late 90s, I didn't know there were standards. I was just told to make some Ethernet cables. They just assumed I knew what I was doing, and so I just started making them, and they worked. And then one of the upper IT people come by, and they were like, "Why are you doing it this way?" And I was like, "Well, you said to make Ethernet cables, and I did, and it's working." I said that the signals are going through. I'm getting the wiring to work. And then we looked, and that was before you could look a lot of the stuff up on the internet, but we went and looked up I think we might have looked it up on the internet. If not, we pulled it out of a manual, and he showed me this standard here, the A and the B standard, and it doesn't matter which one you use as long as you stick to one of them as you're going through doing all of your wiring. Now, as far as memorizing it, I don't memorize it. As far as the question goes there, the good way to memorize it. As far as I know, I don't think there's any Network Plus exam question on the wiring standard. There might be one question on there, so you might kind of memorize this right before the exam. And then, but I don't memorize this because this is just knowledge that I don't really need to know to keep in my head. I mean, I know the standard, but you saw what I just did. If I need to go back to the standard, I go pull it up on the internet, and so I go pull it back up, to on there. And to know which standard to use, and that's not a good. I don't even like that image there. Let me see if I can pull up a better image here. And I like this image here because it's, well, let's see here. Like this image here. This one works a little bit better there because it's showing you the wiring on there. That's a regular just a regular Ethernet cable. If you do a rollover is just taking all the wires. See, this is a crossover right here. And the reason it's called a crossover is because you're crossing wires. A rollover is where you just take, or that's a straight through. White, green, green, white, orange, blue, blue, or white, blue, orange, white, brown, brown. That's a typical straight through. And then a rollover is where you take one end and you just roll them over, and that's kind of like a console cable. We don't use those very often, a rollover cable. But a straight through cable we use between two computers. If you were going to hook up two computers together and you just had two regular just network cards, you would use a straight through cable. That would work. But newer computers and newer networking devices will do auto sensing anyway. And then, of course, we use a crossover and standard cables. So you have to have those cables crossed like that. But like I said, a lot of the newer equipment is auto sensing anyway, as long as you have it. Well, it's just auto sensing. It senses which wires go where, and it'll fix it for you. Some of the newer stuff. But you'll come across equipment that's not that way, so you do need to know how to do that properly. There's another question on, you had trouble with 5335 packet tracer activity, configuring layer 3 switches, but no, well, Sarah, that's what we're here for the seminar. So I'm here in this particular seminar so I can answer questions, and then next week I'm going to go through some of the labs, and we'll go through some of the material too. But you were saying you had trouble on with the 5335. Where is the 5335? Is it 5335? I'm not seeing the 5335. Which module was that in? Oh, it was in the chapter material? Oh, was it an extra one? Oh, it was not one that we were turning in for my course. Okay. Let me go here to, I don't think it'll be on my assignments either. Well, and it's always good to do the lab. I mean, if you do the labs even on your own, you're still learning how to do those. If I can find, let me see if I can find it, even though it's not graded. Nope, I'm not seeing the 5335, and I don't think I have that lab downloaded out of the material. Let me see if I can find it in files here real quick, because we'll go over it real quick, because it's always good to go over the material. Let me see if I can find the labs. 5335. No, where did you find that, Sarah? Then was it? Said it was in the chapters? Is it in here? In the content? Really? Five three three five. Oh, okay. I see where it is. Okay, it had it linked. Okay, there. 5335. Are you talking about the configure layer 3 switches? The packet tracer here. This one. Oh, okay. I'm gonna clear some of these questions here. Okay, and this is configuring the layer 3 switches. This is the packet tracer. Let me download this here and open that up. And what particular area did you have problems with? We'll take a look at this lab. I probably won't walk through the whole lab, but what I'll do is look down through it and see where you had a problem. We can cover that. See if there was a particular area that you had issues with. Let me just move this over here. Let me fast forward time there to get everything up and running. Switches running, routers already configured. Okay, Sarah's saying she was trying to configure the switch. I got it configured, but the G01 wouldn't change to up. Okay. the MLSW1. You were configuring this device here, and you connected that. Okay, so let's look down through here and see if without going through the whole lab, maybe let's see what we need you to do here. So let's see. Network administrators are replacing the current router and switch with a new layer 3 switch. So that's a layer 3 switch that we're going to replace. So I want you to take the layer 3 switch and replace it with the regular switch 1. Is that what they're having you do on that? So network administrator currently replacing the current router. The network administrator's job to configure. Activity against a score of 8 of 10 because the device connections for the P series are scored. You'll delete and restore these connections in part 2. Oh, okay. They were having you replace your R1. I just haven't got there yet. So normally a production router would have more configurations than just interfacing IP address, and that's true. But to expedite this activity, only the interface IP addressing is configured on R1. So you want to click R1. So what they're wanting you to do here is go into R1. We're not going to do a console cable on the packet tracer, which is nice with packet tracer. We're going to go into the command line here. We're going to look at and what you would do is you could download the configuration, or you could check all of the links. Let's see, we can do a show command. Let's see, we can show interfaces. Show interfaces. You can check your interfaces out. So you can write that information down. Show IP interface B. Okay. You can check out your different interfaces. Check out all the information that's set on them. See, we can go through and check all that, and that's basically what you're going to do with that. You're going to get all of your information off of there, and let's see if we're going to do a show interface, and let's do a gigabit Ethernet 0 if we're going to check that one out. See if we can check out the information on there. You can go in the configuration and check out the information that's on there. And what you're going to do then is you're going to configure. You would go in and configure the MLSW1 with the same information, because you're going to have this connection in. See, because we're connected in here on the, well, I have to reopen it back up now. I deleted it off there. You're going to connect into the same interface. Yeah, I know, packet tracer. It's easier when you have physical wires in your hand and you're plugging them in versus packet tracer. Packet tracer is it's a nice program, but it doesn't replace the real world. And you're just and so you're saying you had trouble getting the configuration on here, the interface configured on your MLSW1. Excuse me, my voice. This winter weather is messing with my voice. Okay, just take your packet tracer file and just email it to me, and then I'll take a look at it and see what's going on with it. But essentially what you're doing here is you're wanting to make sure that you have these interfaces configured the same way for the MLSW1, and then what you then can do, see, we've got that gig 00, and then you'd be, after you get MLSW1 configured, then you can take your lines and plug them in, and we're going to go in the gig 01 there. And what you'd have to do is and then you can move that router out of the way, and you'd be plugging in. We'll use 01 there. We'll use 02 here. And then what you would do is once you get those up and running, then you would just did you do your set your lines to be up? Okay, you did that too, and they didn't want to come on. Okay, yeah, just send me your packet tracer file, and I'll take a look at it. It's probably something in packet tracer. It's probably just something small in there. Probably not that big of a deal. And then let's see, yeah, and that's all they're having you do is they're just having you, yeah, just because the main thing is you got to make sure that you turn it back up, turn it back on, because those interfaces aren't turned on. And then, yeah. And then you'd have to take these connections here and actually, no, I think that's what they're doing here. No, that's what they are having you do. I'm just going to delete that. They're having you get rid of this switch too. So you'd connect those PCs directly into the MLSW1 as well. So you'd have to configure those into the right way too. Okay. So back to the modules here. And rolling down through. So session 5, session 6. So session 5, so there was no other questions on the Ethernet cable. Connecting a wired and wireless LAN. Are there any questions on that lab? Anyone in particular? No? Okay. I'm not seeing any. If you have any questions, I can go back to it. What I want to do is cover some of the network material here in session 6. And I know this was what you covered last week in your course, but I just want to go back over it and talk about it and just lecture through this a little bit, see if anybody has any questions. And those are Professor Messer, and he's actually got pretty good. Yeah, I tell you what, I'm not going to lecture through those because he actually discusses it much better than I do. What I do want to talk about, though, is, let's see here. I wanted to go in here. I do want to open this back up because I did want to cover. Let me see here if I can find it. The MAC addressing. Here we go. And I cover this in my PowerPoints for, I think, Chapter 8. But what I want to cover here real quick is talking about the MAC address and what the MAC address is. And like I said, you went over this last week in your course, but I just want to go back over it to make sure everyone is comfortable with this material. The Ethernet MAC, what the Ethernet MAC is, it's a machine address code. It's a code that is hard-coded. And let me just, and yes, everybody take a big deep breath. I'm using Wikipedia. And yes, I use Wikipedia quite frequently. I just don't use it as my primary source. And I said machine address code. It's the media access control address is the MAC address, or media access control. Sorry, I misspoke on that. Media access control, it's what we call the MAC address. Every network device that gets created for, every network device that gets created is assigned a MAC address. So it doesn't matter if it's a wireless device. It doesn't matter if it's a network card that's going in your desktop. It doesn't matter that if it's an iPad, a cell phone. Doesn't matter. It gets a MAC address, and that's the standard for networking. That is governed by the IEEE 802 network technologies. It falls under the IEEE 802. There's an RFC. If you go out and find the RFC for MAC, if you've not looked up RFCs before, if you go out and find the one for, let me see if I can find what governs, which RFC controls that, but I'm not going to find it. If you ever want to look up RFCs, those are what they call requests for comments, and you can find them on a couple of different websites have them out there. Let's see, here's the IETF.org. This site has them, and you can go find all of the RFCs, and these RFC pages, when you start getting more in-depth into networking, these RFC pages are what governs networking and governs the technology. So if we go to RFC pages here, I'm going to have to allow this site to work. If I go to the RFC pages here, oh, there we go. And we can search down through. No, I'm going to have a topic here. Let's look at the index here. And you can go down through and look at the RFC indexes from 0001 all the way down through, and you can go down through. There are so far 7,465 RFCs, or what they call requests for comments. And depending upon what you're looking for, let's go let's just pull one up. Let's just do a search page here, and let's just do 850. I'm not even sure what 850 is. That's the standard for interchange of Usenet messages. That was the RFC page. And then if you open that RFC 1036 up, and I'm going to allow it. Here we go. And then if you go down through and you pull that up, and it'll tell you if it's been superseded. And this one has been obsoleted. It's been obsoleted by 5536 and 5537. So if we go then to RFC 5537, that outdid those two. But then we can pull this up, and this is the document that governs this particular area, Net News, Architect and Protocols. And what this does, and if you ever need reading that's going to put you to sleep, or if you get excited about stuff like this, you can look down through it. But these RFCs are written out instructions on how that particular protocol or that particular item is going to work. And it's the standards. It's what we call the standards for how it's going to work, and it lays it all out. It constructs. It says here's how things are going to work. Here's how it's all going to lay out for this particular area. And you can find these RFCs on everything from Ethernet to the standards. It's all out there. There's all of these RFC documents out there, and you'll see them from time to time in different places. You'll see that this RFC governs X, Y, and Z. This RFC governs A, B, and C, and you'll see that in the material. So I just wanted to show you that you can go and research these when you get more in depth into networking. For what we're covering in this course, you probably aren't going to go check out RFC pages. It's when you get up into higher echelons of networking is when you're going to get into these RFC pages. But I just wanted to show you that you can go find those. And when we're looking at the media access control, that is governed here, and it's set to say that, excuse me, that when they set a media access control, it's a 48-bit address space, and it contains 2 to the 48th power, or the possibility of whatever that number is there. Let me see, thousands, millions, billions, trillions. Is that trillions? Maybe I'm wrong here. Let me see. That's thousands, millions, billions, trillions. 281 trillion different combinations of media access control. And what happens is that 48-bit space, the first part of the MAC address, or what we call the organizational unit identifier, is given to, and that's the first 3 octets. We're looking at the octets. That's the first. Let me look at one right here. Let me pull one up here. Let me pull a machine address or media access control. Let me pull up an example of one down here. Here we go. This might be what one looks like right here. And let me just put it right here. It might. There we go. And so this part right here is your organizational. The 12, 34, 56. Now, that's not a 12. That's 12 in hexadecimal. So that's not the actual number 12. And I'll talk about that here in a second because I wanted to cover hexadecimal with you real quick. But this is the. Let me go back up here so I can show you on the page here. The organizationally unit or unique identifier, the OIU, and that is assigned to companies that are creating network cards or devices that are going to connect to the network. So you can look up a OIU or you can look up a MAC address based upon that number. So I can go on here on my network, and I'm not going to do it that way. Let me go here to command prompt, and I can do IP config, and I can find my MAC address. There's my IV, there's my V6, there's my tunnel adapter. There's my, let me do it that way. Pull all my information in. Excuse me. Here is, well, if I'm at the V4, okay, right here. Here's my physical address, 56271E. And if I look that up, 56271E, 56, what did I say it was, 27-1E, and I looked that up. we can probably find that's GCS Tech MAC address vendor. So let's look that up and see if we can find the vendor. And so here we go. So this list here shows us that Xerox has the 000 all the way up to there, and I'm looking for 5627. So if we scroll all the way down to 56, let's see, there's 56, 58, 54. I'm not seeing 56 on here. They're not showing 56. That's interesting. Well, anyway, so you can see here on this search, for example, Cisco is assigned 58 BFEA. So Cisco is assigned 58 BFEA. So whoever created the network card for my computer for this laptop here has 56271E. And then what the company does is the last three hextets here are then unique to that vendor. And those are going to be unique. They're going to be assigned by the vendor, and they're not going to assign the same one. Every network card or every network device is going to get a new unique number. So you can always look up the vendor by the first three hextets, and then you can look up the last three are going to be by the vendor. Now, when I'm talking about hextets, if you want to do, let's go back here. So we talked about the media access control. What I want to show you then on the hexadecimal numbering, if you haven't learned binary yet, binary is our base 2. If you go to my YouTube channel, I've got some videos on how to do binary to decimal conversion on base 2. Hexadecimal is base 16. We start counting at 0. And let me make this site a little bit bigger here for you. Well, it's not doing it for me, is it? Oh, it's the Neti site. It won't go any larger for me. Excuse me. But I've got them fooled. I can do this right here. And, oh, no, I can't. Hold on. I'll do it this way. I'll throw it into a Word document and make it larger. There we go. So when we're talking about hexadecimal, hexadecimal is base 16. So when we count decimal, if you're familiar with back to grade school, and when we're in kindergarten or first grade, we start counting and we count 10 and we use our fingers to count and we say 0 because 0 is a number, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our first 10 digits in our base 10, or dec, which is Latin for deci is 10. So we get decimal, base 10. And so we have our first 10 numbers, and then when we get to 9, we start back over again. And then we have our tens group, 10, 11, 12, 13, 14, all the way up to 99. And then we have our hundreds groups, 100, 101, thousands groups, all the way up. Binary is 0 and 1, and it's base 2. It's either off or it's on. Hexadecimal is base 16. So when we get up to 9, we don't start back over again. We add the characters or the letters A, B, C, D, E, and F, which gives us the 16 characters. So when we look at that, we have 16 digits. And that's what we talk about hexa, or 16. Hex is, I believe, 8, but hexadecimal is the base 16. If I'm getting the Latin right. I'm not a Latin scholar, so don't get mad at me if I do that wrong. So when we talk about hexadecimal, then an equivalence, if we're going to do 0, 1, and this is what we call is a hextet. So let me do this so I can make it larger again, because I know that's not very large on your screen. I don't know, maybe can I make that larger? No, the screen snippet doesn't let me do that. Let me see if I can use my easier program here to do it. I know I can draw on there, but and options, can I zoom? Yeah. Oops, wow. There we go. Mamma mia, that's huge. Okay, so let me turn my pencil on here, my pen, and I'm going to go red, F3. Oh, come on. It's not going to let me. Yeah, okay, anyway, I'm just going to do it this way. So we have our hexadecimal, and this is what we call a hextet. It's going to be based upon we're 2 digits, and just like we were looking at we go back to our here, and we were looking at our machine address code. Oh, here we go. We were looking at our machine address code. So, for example, that is not the number 12. That is the 2-digit code, and if we go back up here, and you're not going to see 12 here, but if we wanted to convert that to the decimal number, we can let's use our Windows calculator. If you change your Windows calculator from standard and change that over to programmer, you can convert from decimal to hexadecimal. So let's put the hexadecimal number of 12 in there and convert that over to decimal, and we get the actual decimal number of 18. So when we're looking at this, when we're looking at here, this is hexadecimal, and 18 is our decimal number on there. And the way we convert that is it's just simple that that's when we're looking at the numbers there, you have to convert. Well, I'm not going to go in here on how to convert hexadecimal to decimal. I'm actually going to do a video on that, and I'll post that on YouTube, on my YouTube channel. But just for now, so that you know that you can use the Windows calculator for this. If I was going to do the next one, see 34 would be, so we do hexadecimal of 34, and decimal, that's 52. If let's skip on over here, and if I was going to do BC, I was going to do BC in hexadecimal, so we do BC, and that's actually 188, because you have the B, which is well, I'm not going to get it. I won't go into it here on how to do the conversion, because it takes a little bit of explaining to do, and I want to make sure I lay it out for my video. But you do the B and the C, and then that converts it up to the hextet, BC hextet, and that's 188. The reason we use hexadecimal, if you're wondering why would we even do this, because this looks really confusing, why wouldn't we just use 188? Well, the reason is, if we're looking here, B5, if I'm doing B5 here, and I do that in hexadecimal, and I go B5, that's actually the decimal number of 188 or 181. So instead of writing 181 in here, I can just write B5. So what happens is I can write very large numbers, decimal numbers, and I can write very large binary numbers in a smaller amount of space, and that's why we use hexadecimal. So if I convert that to binary, let me convert this over to binary. Now you see how many more digits that takes up in binary. And so instead of writing out on my machine media access, my physical address, my MAC address, instead of writing out 10110101, I can just write out B5. So that hopefully makes a little bit more sense to you on why we use hexadecimal in our networking world. Let me close that. I'm not going to save that. Close that. Close that. I guess I could have just pulled up there. And then we've got the broadcast. Broadcast is all Fs, which means it's all FF. If we converted hexadecimal FF over to decimal, that's 255. RN binary, that's all ones. So if we turn all of the bit places on to turn them all on, FFFFF, that's our broadcast. Unicast being going to a particular MAC address. The broadcast going to all F, which means they're all turned on, which means it's going to go to all devices. And then multicast is going to be going to multiple devices. Not necessarily all devices, but multiple devices. Now, why would you might ask yourself, why are we using MAC address instead of IP addressing? Well, back in the earlier days, we had MAC addressing because we didn't necessarily have IP addressing set yet. And we didn't need IP addressing back in the day because the first networks, the first computers, and I'm just going to use this as an example right here, they didn't need to be routed anywhere. So the MAC address worked just fine on sending, and let's just go here. So, and I'll just use the little graphic here. It worked just fine sending items out, and I'm going to go back here to the broadcast. And if I needed to send a broadcast out on my network, it could go out. I could show it to my hub or my switch, and it would go out to all my devices, and I didn't need to have that routed anywhere. But when we started coming up with the need to route or use routers, they had to come up with a better way to do that, and there was a period of time where they come up with different ways to route information, but the standard become Internet Protocol, or the TCP/IP protocol, and then IP addressing was what was settled on as the standard. It's what, for the most part, everybody uses now, unless you have some kind of weird network that you set up that you do use some other kind of protocols or some other kind of hardware. But everybody, for the most part, I don't say everybody, most everybody uses the TCP/IP protocol now, and then we use the IP addressing to do the routing, because the media access control doesn't give us the ability to route. One, we don't have enough MAC numbers. When we went back to the, if you went back and looked at the 16 trillion, you didn't have enough. You didn't have enough numbers to do proper routing. So they come up with the IPv version 4, the earlier versions, but they settled on IPv4 way back in the day. And then in 1995 they settled on, or they finalized the IPv6, and then now we're today still rolling over to IPv6. You don't have to worry. Well, we're not studying about IPv6 yet. That's in PowerPoint Chapter 8. So when you get to Chapter 8 in the course here, and you see those, that's where you'll see the IPv4 and the IPv6. Now, when we get to switching, just think of switching is different. Switching is different than routing. Switching uses the MAC address. It's a layer 2. We do not route it, so it doesn't need to be the layer 3. And this is, when we set it, it uses the MAC table. And it goes through and it uses those MAC frames or those frames, and it just sends it through. So very simple, very easy. But there are layer 3 switches, and I'm not going to really discuss those here in class. I mean, you can look at them yourself. Layer 3 switches allow for routing, but they can also do MAC routing. So does anybody have any questions on that material? I'm showing right about 8 o'clock right now, so I'm right where I wanted to be as far as time. So if there's no question, if you have a question, put your question in at any time, by the way. I don't know if I said that earlier, but if you have a question at any time, go ahead and type it in the question box, and you should be okay, and I'll get to it. If I don't get to it right away, I'll see it on the question box and answer it. Okay, so session 7. Let me and you can go check out these videos here. They're I think they're all by Professor Messer. Let me pull these up. Yeah, I think they're all Professor Messer, and he's got some really good information. Let's see here. Yeah, that's Professor Messer. He's got some high quality videos done. I would never even try to compete with him, but he's got some good information there to look those over. What I wanted to show you is at the network layer, and this is where we get into routing at the network layer, and I wanted to see if anyone had any questions on any of the material for these. We use the network layer protocols. We use the OSI. You can also use the TCP or the other model, but you need to know. I just want to reiterate: you need to know this OSI model to pass the Network Plus exam, and to, well, I wouldn't say to pass this course, but there's going to be questions on the OSI model. So you need to look up the OSI model, and you can Google it. I will tell you that there is tons of information out on the OSI model. You can look it up on Wikipedia if you don't like what Wikipedia is talking about here, but this is an excellent layout of the OSI model, and it tells you that, in fact, that's probably one of the better ones it's done. It shows you the layers. It shows you what's encompassed in those. It shows you what the function of that is, and then it shows you some examples of some of the protocols in there. For example, at the data link layer, the layer 2, we use PPP, we use IE 88802. At the layer 3 networking, we use IPv4, V6, IPsec, AppleTalk. Well, AppleTalk, yeah, it's kind of gone by the wayside. IPsec, yeah, kind of gone by the wayside, but we pretty much for the most part use IPv4, IPv6. There's more in here, and when you get in the chapter for the Netacad course, you're going to find more examples in there of the actual protocols on there, but this is a good layout here, and you do need to know this. And again, this Wikipedia page is really good for reading down through here and learning this along with the chapter material. But you need to know the OSI model for the Network Plus. You're going to get the Network Plus. You're probably going to get 3 or 4 questions, maybe 5 questions or more on there. For this exam, for this course, you're going to get 2 or 3 questions on there for the OSI model. So this is one of the things you just need to memorize. Use some type of acronym. I use Please Do Not Throw Sausage Pizza Away. Let's see if there's some other ones out there. Hopefully they're all safe for work. Let's see. Yeah, I'm not going to pull one up with my... Yeah, I'm not going to pull those up because you never know what I'm going to get. I use Please Do Not Throw Sausage Pizza Away. Some people use All Planets... there's another one. All Planets something. I don't know what that is. I use Please Do Not Throw Sausage Pizza Away. I like pizza. I don't want to throw pizza away, and that's something I can remember. And then what I do when I go into my exams, whenever I'm going to do an exam that requires the OSI, of course, I memorize this, but so I don't have to keep it in my head. I go down through and I, write it down. Please do not throw sausage pizza away. And then I know that's the layer 1, layer 2. Of course, I do this backwards from what it's showing on here, but that's okay. Or you can do it, you can write it backwards. If you wanted to write it backwards, and you say, that it's A, D, or excuse me, A, P, S, T, N, D, P, and then you can say, that's the physical link, and I'm doing these off memory. Data link, network, transport. Transport. I had to cheat. Transport, session. I'm going to cheat just for the sake of time here because it takes me a second sometimes to remember. Presentation. And this is what I do, and then that's application. This is what I do when I go and take the exam, and I also just make some quick notes because you are allowed to write notes down once you're into the exam. For the Network Plus, they give you a little whiteboard, and just do a data dump. What I do is I write down everything that I can remember. I write down the OSI model. I write down some other things that I know I'm going to need. And then at least then I don't have to remember what Please Do Not Throw Sausage Pizza Away. I've got it right in front of me. And so then it's a memory jogger for me. I can look at my notes then real quick. But you need to know these. You need to know this OSI and what it does. And you're going to be learning this OSI all the way through this course. But again, you just need to know what it's doing. In Chapter 6, we're learning about the network layer, and this is the routing layer. And you need to understand that this is where all of the routing is done, at the network layer. This is where routers do their work, and that's why they're called routers, because they route. And so the computer does its addressing. It assigns an IP address. In this case, it's showing a V4. The data goes through and gets encapsulated. And when it encapsulates, it's taking the data and it's adding information to it as it goes down through. At the presentation layer, it adds some data at a session. When it gets down to the network layer, it adds the routing information, and it creates a segment. It encapsulates it into that, and then it creates a packet, and that packet is encapsulated with data, and that frame then gets converted into binary, 1s and 0s. That 1s and 0s are that signal, whether it's electrical going across a copper wire, or whether it's a light beam going across a fiber optics, or whether it's a radio signal going across a satellite dish. It's 1s and 0s. So essentially, even what we're sitting here doing right now, I'm talking to you, and my computer is taking my voice, converting it into, at the application layer, it's encapsulating it down, it's routing it into 1s and 0s, sending it off to GoToMeeting, and then coming back to you. It's going through routers, and then it's coming back to you, and on your end, your network device is de-encapsulating it and unwrapping all that data and then presenting it to you as my voice. Now, if that doesn't cook your noodle, I don't know what is, because every time I think about this, I just sit back and go, this is just the most amazing thing in the world, that people have figured this out, how to take my voice or video of me, a TV signal, video, and send it across the internet in 1s and 0s, and somebody else across the globe can read it or hear my voice. It just still amazes me. I mean, even though I understand how all of it works, it just still amazes me that we can get this to work this way. But this is what's happening at the network layer. The protocols at this layer, you have some older ones, the IPX, SPX. That was the Novell back in the day. Novell had their own protocols. AppleTalk had theirs. Microsoft had, I'm drawing a blank on the top of my head now, what Microsoft was using. I'm drawing a blank now on it now. It was they had their own protocols too. And we're really not going to cover those legacy protocols. There was a connectionless one too. But we have all, for the most part, the internet, the world, the globe, has set the standard on the TCP/IP model, V4, and now we're moving to the V6. But that's the V4, V6 that we're currently using. We're using them side by side. It is the current protocol. So what does that protocol do? The protocol is what tells all of the devices, wherever they're connecting them, it's telling them how to talk to each other. So let me give an example of what we're saying. So I'm talking to you in English. At some point in your life, you were taught how to speak English, and you were taught how to understand English. At some point in my life, I was taught English, how to speak, well, questionable sometimes with my Southern accent or my Texas accent comes out, and I start using y'all and things like that. And I start getting back into my Southern drawl, which I tried, most of it's gone. But I'm speaking in a language that you can understand, and I'm transmitting information that you can understand in a protocol that we can all understand in this room. If I was speaking in French or German and you didn't speak French or German, you wouldn't be able to understand me because I would be speaking in a different protocol. So what happens is these protocols are set so that all of the devices can pass that information along. They all understand the links. They all understand that when a packet comes through, when it gets the IP header, it's got the IP information on there. It knows how long it's supposed to be. And it knows if it's not long enough that it dropped data. It knows that if it was too long, then something else is going on, that that things are out of sync. And that's where websites, you time out on a website or data doesn't come through properly or you get a corrupted file. That's usually what's happening is at some point the ones and zeros didn't come across properly. Now, when we talk about the characteristics of IP, the IP protocol, and I'm not going to do too much lecturing on this. I'm going to cover this at a very high level. You need to remember, and this is I will guarantee you this is on the test. I guarantee you this is on the final exam for this course. You're also going to see it on the Network Plus, but you need to know the characteristics of IP. You need to know that it's connectionless. What it means is it's the honey badger of the protocols. It sends the data and it don't care if it gets there or not. It's connectionless. It's basically what I'm talking right now. Doing this media is connectionless oriented. It doesn't care, and I think one of you had made the comment that my voice was breaking up a little bit, and that is caused by being connectionless. If you've ever used a program called Skype, or you've tried to do something across the internet and it kind of gets choppy, that's a connectionless connection. That's a connectionless protocol that's being used because not all of the packets are going through properly. And it's connectionless, so it sends it through, but it doesn't matter if all of them get there or not. You may lose the signal at some point. Sometimes web pages, when we connect to those are connectionless because not all the information gets there. Although I believe on web pages, it is connection oriented, but video streaming, voice streaming, YouTube channel, those things are connectionless. It's best effort. It's unreliable, and it's also media independent. It's independent of the media, and when I say medium or the media, I'm talking about the cabling or the fiber optics or the satellite signals. It doesn't care because at that point it's converted into ones and zeros. It doesn't matter what media it's going across. Now you might ask yourself, why would they create a protocol that's connectionless and that's unreliable? Well, it goes back to the days of that we didn't have very much bandwidth. We had very low-end connections, or the connections weren't. We couldn't send a lot of data through. Think of it back in the days when we maybe only had 2-lane highways, and so you couldn't put a lot of traffic through those 2-lane highways. So they had to come up with a protocol that they could get data across, that they didn't have to be sending data back and forth. because that's what we get into when we talk about the UDP protocol or something along those lines. You have to have connection oriented, or it has to have you get back and forth, and that creates more traffic. So this protocol, the IP protocol, cuts down on traffic. So essentially, at a very high level, and I'm explaining this like at a very low level, that it's because of bandwidth is why they did that. So it's connectionless. It does best delivery on that. So, and looking, I'm not going to lecture through this. This the IPv4 header, what it looks like. Much larger than what they did with the IPv6. When we talk about the IPv6 header, when we talk about the limitations of IPv4, we're running out of them. This is the sample IPv6 header. Oh wait, let me go back here. You can see that it's much simpler. They've simplified it. They've removed some of the complications. So now we used to have this for an IPv4 header, and so you had version, you had internet length, you had these different protocols. You had total length, you had time to live, protocol, source IP, destination, options, and then padding in there. But then when we come along with IPv6, they've simplified it. So now we just say, what version is it? V6, traffic class, payload length, next header, hop limit, and then our source and destination. So they've simplified it down on the V6, so it makes it a lot easier to understand. And I'm not going to go through the routing there unless anybody has any particular questions. And the last thing, if you have questions, pop them into the box there. I'm just going to lecture through real quick on, or make sure there's no questions on any of the labs. You should be doing your skills tracer integration challenge. Kelly, let me answer you offline on that, since that's and just so you know, I don't think again, can somebody answer this question? I don't think you can see each other's questions, can you? I was told you could not, but I don't know from my end. I can see everybody's questions, but okay, that's what I thought. So it's supposed to keep it private in case you ask a private question. So yeah, thank you. Yeah, Kelly, let me answer that offline for you. I think I can answer that offline for you. Okay, so that's I did a very high level of session 7, but I just wanted to get some of the things that you need to know, that you're going to need to learn. You need to learn the OSI model. You need to be familiar with IP and what the characteristics of it are. And you have a couple labs this week. You have the 16435 lab and then the packet tracer integration. There's additional packet tracer exercises there if you want to do them. That I don't believe they're graded. Your course may look a little bit different than mine. I have mine I believe is set up like all the rest of the courses across the state, but just in case. It may not be. There may be extras or that they've put in there for you. Okay, the seminar, our seminar is set to go from 7 to 8:30. I lectured a little bit more. Typically what I'm going to do is lecture from 7 to 8 and then leave the last 30 minutes open for any questions. And that's what I'm going to do here for about the last 15 minutes. If feel free to log off if you don't. That concludes the lecture portion of the seminar. I'm going to answer. Oh, good. Sarah got her lab working, so awesome. And I'm going to leave the rest of the time open for questions. If you have a question, go ahead and pop them in. I'm going to remain on here for about 15 minutes or until everybody logs off. Well, whichever comes first. Or, well, no, I won't just bail on you. I'll keep the recording going as well for anybody that's listening or watching this later on. And if you're wanting any information on how to do binary conversion, I've got videos out there on my YouTube channel for that. As we get into subnetting, I've got videos for that. I'm going to cover subnetting in a future seminar here, but I've also got videos on it, and I'm going to do a video on hexadecimal. I just haven't put all the information together. It takes me a little bit to get videos together. For one, I have to review everything and make sure I know what I'm talking about. I mean, I know the material, but I have to review it again to make sure, and then I have to make sure everything's set up, and then Takes me a little bit of practice to get them ready. Sarah, go ahead. Ask your question. And if not, feel free to log off. You don't have to remain on here unless you're wanting to see what other questions are being asked. And thank you for attending seminar. Appreciate your time. Very much appreciated. And hope everyone has a great week. Stay warm. I know it's supposed to be down around 0 again tonight here in my area of Indiana. I'm over by the Richmond area. And it's, man, it's just been a harsh winter. Makes me want to move down south again. Okay, Kelly, that's fine. I got it. Sarah, let's see. Sarah's saying that the first ping through the new layer switch times out. It's probably the ARP table building. Yeah, and it could be Packet Tracer. Packet Tracer does some goofy little things sometimes. So it could be Packet Tracer kind of being goofy on that. Because of Packet Tracer the way it is, it may not build its ARP table as fast. What you might do is tell it, click a few times on your Packet Tracer, where you do the, let me see if I can pull my Packet Tracer up here, where you do the time, set the time, where you do fast forward time. That might get the ARP table built faster because it might take it a few minutes for the ARP table to build. Or for it to build the information. So if the first one times out, but then all the rest of them go through, if it's just the first time, it times out. But if it's the second time you do it and it's still timing out on the very first one, then that's something weird going on. Yeah, you can still send me the PKA file, the Packet Tracer file. All right, you too, Christina. Have a great week. Okay, Cecilia, is there a trick to using TerraTerm in the lab? I've never been able to get it to run. Let me see here. TerraTerm, it's well, you should be able to. Whatever. Are you running it in your home lab, or are you running it in a lab at Ivy Tech? Because it usually runs fairly simple. I don't have it on my laptop here at Ivy Tech. You might get one of the lab assistants or somebody there to help you out with it. It should run. It's and you should be able to just use the default settings on there. I know I've been up to the Terre Haute labs, and theirs runs just fine. At the Richmond labs, we've got ours running. But it should be tested and running. Yeah, you should be able to get it to run. The 234 lab, but I was using it for the distance learning. Oh, okay.